Okay, hello everyone. So in today's video, we'll look at something called as autoregression. We'll try autoregression and we'll try to predict a few values. We'll do basically autoregression of the order n in Matlab. So let me start with sharing my screen with you guys. Okay, so I'll use my previous code and I'll use the previous data files that I have. So this is the data that I have. Okay. This is taken from stocks basically. So I will be discussing this only, and what we'll do is we'll focus on a single column. We'll focus on this time series only, this fourth column basically, and based on the pattern we'll try to predict what could come here. For example, what could be the value here. So let me start by doing this. Let me start by running this code. Okay, so the algorithm that I'm using here is, hold on. Let me just change the algorithm and let me go to my kappa values. All right. So let's see the fourth column first. Comma 4. This is how my data looks like. Again, as I told you that I've taken this data from stocks. So this is how my stock look like. And by the way, these prices are taken at every 30 minutes. Okay, so now let's see autoregression. What is meant by autoregression? So focusing on the fourth column only. This is my fourth column only. So let me go back to my Excel file. Okay, and let me just copy it. And let me open a new sheet. So let's say, all right. Anyways, let's just copy it and let's just paste it here. Let me delete all the values which are here. Oops, where is it? I am sorry, actually it's a problem. Just give me 1 minute. And let's say we have data values which are nothing but this. And let me go over there. Okay. And let me just remove these values and let me come here. All right. Alrighty. So the goal is to predict what could come here after 62,021. So to do that, what I'm going to do is I'm going to consider previous n values and I am going to make them as my input. I'm going to ask what could be the next output. For instance, let's consider this group. Let's consider group size of 5. So let's take these values and let's paste them here. Let me see where the transpose column is. Is a transpose. I'm looking for transpose. Okay. I have this group. Based on these 5 values, what I want to do is I want to predict this value. So this value becomes my output. So this is my, let's say, my x1. This is my x2. This is my x3. This is my x4. Similarly, this is my x5, and this is my y. Doing it again, rolling over the window, I get this, and this 40443 becomes my output. Similarly, rolling the window again, we are considering size to be 4 and 31218. Last window for this particular example is this, and we want this will come here and this will come here, 62021, and this is the value I want to predict. This is my blank value, And of course, now you can generalize. I did it for this small group. So you can generalize, you can do this for the complete series. And the next value I want to predict is this. And of course, now this becomes a regression problem, an auto regression problem of the order n, because I'm considering like n five previous values. So I'm going to do the same thing. I'm going to fit, a curve through these, data values, and then I'm going to try and predict what could be this value. And of course, I'm going to do it in my, my Matlab window. And let me just do something. Alrighty. So now we are back into our Matlab window. I am considering this column only, this fourth column only, by the way, and I'm using the algorithm KMCC. And moreover, what I'm doing is I'm going to normalize everything between 0 and 1. And the group size that I'm considering is like 10. That means I'm considering 10 previous value. For instance, I'm considering these 10 values, and I'm trying to predict based on these 10 values what could be the next value. And I'm doing it using the method KMCC. So when I do that, I get an error, a mean square error of 0041. MSC, y is my real value, y underscore estimate is my predicted value. So I get a mean square error of 0.0041. Now let's see, let's plot the real values and the predicted values. So I'm plotting my real value plot y, and this is my, my normalized values. I'm also plotting my y. Sorry, let me write hold on plot y underscore estimate. I'm getting this. Yeah, it's actually not a very good answer. It's not a very good answer. You can see there are so many spikes, and this is all that is happening. It's not a good thing altogether. It's a very bad result. But anyways, that's how we can do, we can convert any time series problem into an auto regression problem, and then we can try to find out the next answer. And let me try if I can find something, if I can try other method, and if I can get, better answer. Let's see. 72. So, and let's see what was 0041 is the MSC value, and here the MSC value is 0094. So again, this method is already better. Let's see if we can improve the result. It was 41. Let's see if we can beat 41 somehow. 0.8. Let's try 0.8. Let's try 0.5. 39. Let's try 0.4. 39. Let's try it again. 39. 0.5 is actually the right answer. Let's try to manually tune this guy. 37. That's nice. 37 again. 37. 43. This is not a good answer. Let's try 7. 40. So we got the best value at 3. Let's try to see how the graph looks like. So let's plot something. Plot the real values. Let's plot the predicted values. Oops, I forgot to do a hold off. Hold on. Plot y. Hold on. Plot y underscore estimate. Let's see. Yeah, the result has somewhat improved, but it has not improved by a good margin. It's still the same. So again, anyways, doesn't matter. I mean, that's what we can do, right? We can, to improve the result further, we have to try different models, which I'm not going to do here. I'm going to try it in a different video. So anyways, thank you for watching, and and upload a few other videos on residual analysis and other things. Okay, so thank you guys. Take care.